Let's get some practice now thinking about how ions typically form, how they might form compounds, and how we name those compounds. So let's start with something in group 1, in this first column. This first column is often known as alkali metals. And so let's start with potassium. K is the symbol for potassium. Now things in group 1 here, one way to think about it is their outermost shell has 1 electron in it. So they wouldn't mind losing that electron. So when they ionize, they tend to lose an electron and become a cation, a positive ion. And so let's look at a situation where I have some potassium that has been ionized. And I could write it just like this. We've seen that in previous videos. And we can refer to this just as a potassium ion. We could refer to this as potassium 1+. We could refer to this as a potassium cation. Now let's go on to the other side of the periodic table, things that would really love to grab an electron. So things in a group in the halides, which is this column right over here. So these are the halides. They have 7 electrons in their outermost shell. They would love to have 8. So they tend to be really good at grabbing electrons. And so let's say we're dealing with chlorine. And chlorine is able to ionize. So it's able to grab an electron. When chlorine grabs an electron, it will be a negatively charged ion. So you could write it as chlorine 1-. But the way that we generally refer to an anion, a negatively charged ion, instead of just calling this the chlorine anion, we would call this chloride. So this we refer to as chloride. Now, as you can imagine, with potassium having a positive 1 charge, or 1+ charge, and this having a negative charge, they're going to be attracted to each other. And they can actually form an ionic compound. And the ionic compound they would form, we would write as, you'd write your positive ion first, and then you would write your negative ion. And this right over here would be described as potassium chloride. Let me write that down. Potassium chloride. Now you might be saying, well, let me rewrite the whole thing. So you know the chloride part, you say, okay, this is going to be an anion, because instead of writing chlorine, which is the name of this element, I wrote this IDE at the end to say, hey, this is an anion. So I know that this is the chlorine anion. This is chloride. Why didn't I do something similar for potassium? Well, the way the convention works is if someone says potassium chloride, you know you're dealing with an ionic compound. And if the chlorine has a -1 charge, an ionic compound, the whole thing is going to be neutral. So if this one over here is 1-, then you know this over here, since they're 1 for 1, this is going to be 1+. So you know that you're dealing with a potassium cation and you could say a chloride ion, or a chlorine anion. You could refer to it various ways, but this is potassium chloride. You have a positively charged potassium, and you have a negatively charged chlorine, which we would call a chloride. In the next few videos, I'll do many, many more examples of this, and ones that'll be a little bit more complicated.